so a free body diagram is especially helpful when you have problems that are more complex, where it starts to help to actually visualize what's going on. For instance, we've done some examples. The box pushed to the right at a constant speed. So this time I want you to tell me, what are the forces on the object for A? What's one force we know? We know the normal force. That's perpendicular from the surface. What else? Okay, I heard weight and I heard friction. If we're pushing the box to the right, then friction would be to the left. Friction always opposes motion. And even after illustrating this picture, we can make some other assumptions based on the fact that we know it's going at a constant speed. What are two forces that are equal if we know that we're moving at a constant speed?
Normal.
Right. Gravity, or I'll just call it force of gravity, equals the normal force. And what else? The force you're pushing with equals force of friction. And again, the reason we know that is because if you're moving at a constant velocity, those forces have to cancel each other out because there's no net force. And net force would imply that there's an acceleration. For part B, we have a wagon pulled to the left by a force 30 degrees above the horizon. So we've got a force illustrated here, 30 degrees above the horizon. What other forces do we have involved in this wagon?
Friction.
Right, friction is going to be in what direction? It's to the right. And what you don't want to do is draw the friction opposite of this force. That's a common mistake. If the wagon is rolling to the left, friction is to the right. Okay, friction opposes motion. Part of this force is lifting up on the wagon, part of it's pulling it to the left. But friction is just going to the right. What other forces do we have here involved with the wagon? An easy place to start when you don't know where to start is objects have weight that always act down towards the center of the earth. And if there's a surface involved, the force that acts perpendicular from the surface is the normal force. So for B, we have weight acting down, normal force acting up, friction to the right when the wagon's moving to the left due to a force up at an angle of 30 degrees.
That means
Right. If you're pulling a wagon, it's like you're pulling up on the wagon. You're not pulling it off the ground, but you're simply rolling it to the side. That's all that means. For part C, like the block that was sliding to a stop, if a car is stopping, for some reason it's up in the air. I don't know why. There you go. Now it's like it's driving on a road. But again, when in doubt, if you don't know where to start labeling the forces and draw the weight down. And if there's weight down and it's traveling on a surface, what else do we have? Normal. And if the car is traveling to the right, in which direction would friction be? Sure would be. And that's all, that's pretty nice. Those are all the forces that we would have. There is no force, even though the car is still moving to the right, there's no force to the right. You're not pushing the gas anymore, you're pushing the brake. So the acceleration is to the left.
So you don't draw anything to the right.
You don't draw anything to the right. That's oftentimes a trick question when they ask you to label the forces. People want to draw an arrow in the direction it's moving. But you don't label the velocity. You only label the forces on a free body diagram. So there's weight and normal force. When you apply the brakes, that's the friction that allows you to stop. There's no longer a force that's pushing you forward. There's only a force that's acting backwards, which is why the acceleration's backwards, which is how you slow down or stop.
So, if you're braking, the friction is still going backwards with the force, or with the friction?
Well, the force backwards is the friction, because when you apply the brakes, it causes friction, with the wheels that are turning. It stops them, which in turn makes the tires in the road have a force of friction between them. Without a force of friction, you wouldn't be able to stop in your car. You wouldn't even be able to turn or go around a curve. Okay. Yeah, that would be kind of scary. You would simply go in a straight line, unless there's a net force, right? Newton's first law of inertia. Right. I'm going to give you a moment to read over these questions and try to draw the picture, solve it, and then we're going to come back and solve it together.